Why the paper towels?
Unwrapping shapes with rotational symmetry is quite similar to unwrapping paper. While a piece of paper is not infinitely thin, a sheet of area with a width of dx is. While the slicing method utilized infinitely thin cylinders to find the area, the unwrapping method uses infinitely thin rectangular prisms. The circumference of the shapes, which is 2 pi r, is represented by the length of the prism, while f of x is once again a function of the height.
Whoa, you just blew my mind.
I like to think of the r as an x when rotating around the y-axis because length is running across the x-axis and the resulting equation will be the integral of 2 pi x multiplied by f of x times dx. All that's left to do is take the integral and solve for the limits.
How about an example?
How about some patience?
Why is there a milk jug on the right?
That isn't a milk jug. That is the function y equals 1/2 x plus 2 rotated around the y-axis.
But there's a hole in the middle.
That's fine. We're only solving for the purple area, which is the solid section of the milk jug.
Oh, I get it. Just like unwrapping paper towels, you can only unwrap up to the cardboard tubing.
Which has a hole in it.
You're a good teacher.
I think you're ready for the next step.
So, the first thing I should do is multiply f of x, also known as the height, by 2 pi x, which is the circumference.
Yup, and in the second step, you should remember to plug in your f of x value, which in this problem is 1/2 x plus 2. And also, remember to multiply by dx, which is the thickness of the prism.
That makes so much sense. The third step is just distributing the 2 pi x to the 1/2 x plus 2, as well as multiplying by dx.
That's right. All that's left to do is take the integral.
Wait, what happens to the dx?
The integral cancels out dx, and if you haven't learned how to take an integral by now, I'm going to be seriously pissed.
Don't worry, I know how. All that's left now is just to plug the limits in. Okay, so when I plug a 6 into my integral, I get 432 pi over 3.
And when I plug a 4 into the integral, I get 160 pi over 3.
So when I subtract 160 pi over 3 from 432 pi over 3, I get 272 pi over 3, which is my answer.